classical Christianity. So
Okay.
y'all, I don't know. I just came up and talked to y'all, so y'all could be the most devout Christians or the most strident atheist or
Well,
somewhere
I will
in
be
between.
honest with you, I am an atheist.
Yeah.
So do you still want me to answer some questions? Or?
Oh yeah, absolutely. This is really just about me sharing a piece of my mind, getting a piece of your mind, and diplomatically, and just talking through any issues.
Okay.
So you said you're atheist.
I mean, I grew up Catholic, I guess, and I haven't really been pursuing it. I was confirmed and everything, but I don't really go to church or anything.
Yeah. You think it's gonna rain?
Do I think it's gonna rain? Yeah, definitely. It's looking really sketchy.
Yeah. All right. So
Should
if
I
we
be
all
worried
run
about
away,
thunderbolts or something?
what's that?
Should I be worried about thunderbolts?
Yeah.
Well, not any
It's
more than
raining down
us.
on us or something.
So I'm Michael, and your names are
I'm Patrick.
Patrick.
I'm Derek.
So this will probably end up in some lecture or something, and maybe YouTube. Y'all are okay with becoming famous, right?
Yeah. Oh, definitely.
I guess.
All right, cool.
Maybe just this once.
So Patrick, you said you were an atheist.
That's right.
Any strong reasons why you don't believe there's a God?
I wouldn't say it's a strong reason. I was raised Episcopalian, and we'd go to church, and we'd say grace, and we'd do all these religious ceremonies and whatnot. But as I get older, I realized I was never really feeling the connection that I was told to feel by like my preacher, by my parents. And so after a while, I just came to believe that maybe there wasn't anything going on, and maybe that it was up to me to decide what happened in my life.
Yeah. So you believe there's not a God, or you just don't know if there's a God, or you believe there is no God?
I would have to say that I believe there is no God.
Okay.
But I guess that's just the way it seems.
Yeah. Do you and so the reasons you gave were that you didn't really feel a connection, or didn't feel like there was a God?
Yeah, mostly. I never really felt that, and as I just got older, I began to formulate my own opinions, and it just turned slowly into atheism.
So what would you say you base those opinions on? Anything other than the lack of a connection, or?
I mean, I guess that's hard to say. A lot of my friends were atheists, and so sometimes we talk about this, and it just seemed to make a lot more sense that there wouldn't be a God, because I started taking like biology classes and everything, and so all these things that had been mysteries to me were starting to become a little bit more clear. And I'm not trying to say like I think it's stupid that there's the idea of a God. I think it's very possible, just based on like what I've seen in my experiences in my life and what I know about the world around me. I would say it's probably very likely that there isn't.
Okay. So what about biology you think shows there's no God?
Well, there's always like the explanation for life, how God was who created all. And just the more I got into the sciences in general, I just saw like, for example, there's a tree back there, and some would say that God made that tree spring up. But then I realized through these classes and whatnot, the more I studied on it, maybe it was a seed that was planted, and that seed then divided into a million different cells, and those cells eventually became a tree.
How does the seed develop into a tree? What
Basically it breaks apart into, it starts with a few cells and these are stem cells that basically have no purpose, and then they start to develop and they get more specialized, and so eventually you'll have cells that are specific for barks, cells that are specific for the xylem and phylum, and cells that are specific for the leaves, and so they eventually just find their own place within the tree.
What tells the cells how to form, or how to divide, or what?
It's just a series of chemical processes based on RNA and DNA and proteins assembling in the right order.
So what's DNA?
DNA is a molecule that determines what proteins and what other molecules will be formed. It's sort of a code written in every single cell of that tree that tells its predecessor, its next cell that it's going to create, it tells it what to do.
Would you say the code on DNA is more or less complex than Windows XP operating system?
I'd say it's billions of times more complex.
Does Bill Gates employ people or persons to write code?
Yes, I think so.
he doesn't rely on chance to write code.
I guess not.
So where do you think the information in the code of the DNA for a tree came from?
I guess that's a compelling argument, but
that's a good question.
I think it does just come from chance. Way back when the universe was created, it was just a super dense particle, and that just by sheer freaking luck turned into this. It could have been any other. It could have been any other possibility, but we simply landed in this one. And that doesn't strike me as too far-fetched, all things considered, because it's just as likely that we all live in this universe as it could be that, I don't know, the sky is orange. You know, it's all just about chance, and this is what we happen to have.
So, you're familiar with natural selection?
Darwin's theory,
Yeah. Do you know about the cheetahs today over in Africa? Are you familiar with their plight?
Something about like they're becoming less genetically diverse.
Correct. So natural selection, they adapted to this very specific environment, and so through natural selection, part of the diversity of their genome has died off.
Right.
And so now their environment's changing a little bit, and as a population, they are less able to adapt to their environment. You're familiar with that?
I wouldn't say they're less able to adapt, but it's just becoming less likely that they're going to adapt, because they are all starting to develop a much more similar genetic pattern.
Right, they don't have the diversity in the information of
exactly.
DNA.
Yeah.
So based on that, do you think it's more likely that natural selection eliminates information from a genome or adds information to a genome?
Well, it depends, because in the case of the cheetahs, they were all in a very specific area, a specific region, with very specific stimuli that formed them over these millions of years. And evolution is all about chance. It's about some random genetic mutation that comes along, and those animals that can use this mutation, if it benefits them, then they will be able to pass on their genes better. So it's still possible that the cheetahs could become genetically diverse again. If they receive a genetic mutation that allows them to better survive, well then that reintroduces diversity.
So just putting mutation aside for a little bit,
okay.
Without the possibility of mutation, I think you would agree that basically a given genome has its certain genes,
sure.
certain information, and basically they can do different combinations of those, and then as time goes by, if certain factors eliminate members out of that genome and they're not able to pass their genes on, then the genome becomes less diverse.
Sure.
It's agreeable. So then we have the mechanism to introduce new genes would be a mutation. So like a flip, or maybe ultraviolet light comes in and knocks a DNA pair around. Are you familiar with experiments on fruit flies where they make mutations in their genome?
Oh, because like they're short in lifespan, so you can see the evolution
Correct.
take place a lot faster. Yeah.
Did you see any beneficial changes from mutation with the fruit flies?
Well, I don't know enough about that to make any kind of claims. So I can't really answer that one too well.
Well, in general, they're not the ones that we can make on a fruit fly are generally not beneficial.
Well, that would make sense.
Yeah.
I feel like it really is all about chance. Like the very, very few mutations that actually turn out to be beneficial, those are that eventually make a difference.
So I think, yeah. So there could be a beneficial swap, but you would agree that it's very unlikely that you would get a beneficial mutation.
Sure, because there's plenty of mutations in each and every one of us right now. Like I think on average there's like 52 genetic mutations in every human being. So it's unlikely that most of those, like 99%, are probably not going to make any kind of change. But maybe there's that 1% eventually that will help us out in some way, and so we can pass our genes on, and then that 1% becomes a lot more common.
Are you familiar with a mousetrap?
Yeah.
You know how many parts there are to a mousetrap?
I don't think it's too complex.
It's not. There's 5 parts. You have the base, you have the spring, you have the plate that serves as a catch, the trigger, and then you got the little mechanism that holds it down. But if you remove any one of those parts from a mousetrap, the mousetrap no longer works.
Sure.
So in our model, in order for a mousetrap to evolve and be beneficial, all 5 of those changes would have to occur simultaneously. So here's my point. If let's say if we took the mousetrap as a function on an organism,
Okay.
and this organism eventually developed a mousetrap, in order for any 5 of those characteristics to help that organism survive and then help it to pass on that information to the next generation, in order for it to be beneficial, all 5 of them have to be there together, or it doesn't provide a benefit.
Fair enough, but it's easy to use analogies like a mousetrap or like Bill Gates to describe this, but the system I feel like is a lot more complex. Like there's so many other factors that could be introduced into this that it can't really be broken down into a single example. Because I can't think of any examples right now. But
Let's take, for example, a bacterium with a flagella.
Okay.
The flagellar motor has 37 unique parts that aren't found anywhere else in that bacteria.
Right. Okay.
So there's more parts that are required for the flagellar motor, but 37 of them can't be said to have been borrowed from any other part of that bacteria. And if you look at that flagellar motor, it has pieces that look almost exactly like an outboard motor on a boat that have the same function. So it almost looks like it was designed, and 37 pieces had to show up out of nowhere, really, in order for this bacterium to have a way to get around.
Sure, but I think what happened is this happened over billions and billions of years. That bacteria, when it first actually became organic, when it first existed as a sentient being, not sentient, but as soon as it existed as a living being, it probably didn't have a flagella. And then over time, certain bacterium with this mutation to allow maybe a piece of that flagellum, one of those 37 pieces, maybe that survived and it passed on that gene, and over time it eventually built up,
right,
just out of the fact that helped it move faster. So eventually the flagellum becomes more commonplace and it becomes the standard fare for any bacteria.
Well, you said that it could partially come into existence and help it, but if any one of those 37 are not there, then it doesn't function. So it can't help the bacteria until they're there.
It wouldn't function in the same way, but maybe just got lucky.
You said another thing you said was billions and billions of years. Do you know how old cosmologists think the universe is, approximately?
It's 13 billion, something
13
like that.
and a half, roughly, billion. But do you know how old they think the Earth is?
Only about like 9.
I think it's 4 or 5. Yeah,
Oh,
4
okay.
billion. But if we were to take the scientist view on life, have you heard about the Precambrian explosion?
No.
So it was around, I think, 200 million years ago that there were simple bacterium before that. Then at that point in time, geologically, within seconds, if you were to put all this on a geological clock, within seconds, from the beginning to the end, 72 of the 74 phyla show up all at the same time. So the space for evolution to happen isn't really billions and billions of years. In fact, they almost show up all simultaneously.
Well, but the case for evolution would say that those organisms who showed up in that explosion are different now than when they first appeared.
No, they're the phyla that we see today. The
But-
72 out of the 74 phyla we see today.
But are they identical to when they first appeared in the Precambrian explosion?
Yeah, I mean, there's horseshoe crabs, there's shrimp that look, maybe a little bit bigger than our shrimp today, but they're still shrimp. There's the plant phyla, there's mammals, there's So yeah, they're basically all the life that we know today showed up around 200 million years ago.
That's interesting, but I don't really see how that's a case for the existence of God.
Well, it's not necessarily a case for God, but it is it's certainly seems to be a defeater for evolution.
Really?
Because the amount of time available for evolution to do its work, and the odds that it has to do it, the unlikeliness of evolution occurring, it constrains it even more.
Well, I guess I'm not really smart enough on that subject.
No, it's fine. It's fine.
To refute that one.
I'm just trying to give you some things to think about. So.
Oh, for sure.
Anything else you?
Some food for thought.
Yeah. I'll leave you with this, unless you have more you want to say. We're kind of been talking about the teleological argument. Telos means design or end, and so if we look at nature and we think that it's designed, or we look at information, so there's life, and we could say that life seems to be designed. Our solar system seems to be designed. There's a number of factors that are in place that allow us to even live on our Earth. If Jupiter wasn't there gobbling up comets and asteroids, if we didn't have a moon that stabilized our wobble, our locate distance from the sun, all those kind of things,
sure.
The fact that our sun's not binary helps us support life. But then there's also design on a cosmic scale, like the weighting of the gravitational force. All of our constants seem to be finely tuned to allow us to be here. If gravity was much stronger, we would all mass would just attract itself so much that it would collapse. But if it was much weaker, then we would just fly apart and not ever form any solids.
Fair enough. But I feel like the point of all this random chance is somewhere out there maybe that is the case. It's just the way I see it is,
well, let me
we're
ask
all
you
here because we got lucky. You're right. If Earth was however far away from the sun, if it was just like a couple billion kilometers away, then none of us would be here. If it was a couple billion kilometers closer, none of us would be here. So we got lucky, and I feel like that makes it seem likely that a bunch of other places could have gotten lucky, a bunch of other places could have gotten unlucky. It's all about chance.
Yeah, the solar system design, it is. I mean, you can take all those things into account, and you can give them a weight, and it still is unlikely that another planet has all of our characteristics that our best scientists think are required for life. But it's true. It could be, yeah. Even taking, like, I think it was 10 to the 14 stars. I believe if there's 16 different factors, so if you give each one of the factors a 10%, then it's 10 to the 16 unlikely. But it still could happen.
It's possible.
But the fine-tuning of our constants, like how strong gravity is, it's a principle that we believe, in order for us to even make any types of hypotheses about the universe, like when we look through the Hubble telescope, we assume as part of that the constants that we experience here are the same constants throughout the universe. So the whole universe seems pretty designed on a razor's edge to allow life. And so
life as we know it.
As we know it, yeah, and because we don't know it any other way.
For all we know, like the factors that we were just describing, like how far away the Earth is from the sun, maybe there is a species out there that can survive when the Earth is a couple billion kilometers, when their planet is billions of kilometers away from the sun. We don't know, and it's quite possible that life can exist in forms we have no idea what they could possibly be right now.
Right, that's true. There is what we don't know, which is why I will move from the teleological argument to the cosmological argument. The cosmological argument comes in several different forms. Some talk about a necessary being versus contingent beings, like the universe, even if it were eternal, would still be contingent because it wouldn't be required. But the simplest form basically says a Big Bang needs a Big Banger. And in its formal stating, it's got two premises. It says everything that begins to exist has a cause. The universe began to exist,
Right.
therefore the universe has a cause.
That's interesting. I wish I knew more on
Yeah.
on the whole argument to be able to talk about that, but I don't know that
Yeah.
much about it.
Yeah, it's just something to think about. It is logically valid, and I don't know if you've taken your philosophy 101 yet.
Not yet.
But an argument that's valid just means if the premises are true, then the conclusion follows by necessity.
Okay.
So then you ask, is it sound? And when you ask if an argument's sound, you're asking, are the premises true? So you got to ask yourself, and you got to judge for your own self. I can't make up your mind whether you think it's more or less likely that things can come into existence without a cause, come into being without a cause. And then you got to.
The creation of the universe is a little bit too complex. I think the Big Bang Theory is one of millions of billions of possibilities. So I don't know. It's hard to pinpoint it with one logical argument because we're so small and the universe is pretty enormous.
It's enormous, but it came into existence, right? It's here. Why is it here instead of nothing? That's really what this question's asking.
Fair enough.
Yeah. And so that's the first premise. The second premise is that everything has to have a cause that comes into being, and then the second premise is the universe came into existence. So just think about those. See if you can think of a defeater or why they would not be true.
Fair enough.
Okay.
Will do.
Thanks, Patrick. And
I appreciate it.
did you have anything you want to weigh in on?
No, I'm not
Sure.
much of a biological. I'm not too into biology. More of exercise science. But
Yeah.
I mean, if you asked me some questions about that, I'd probably be pretty helpful.
Okay.
Not really. Sorry about that.
Oh,
Wasn't
no, it's
too-
good.
wasn't too
Cool.
talkative.
All right. Well, thanks for stopping by. And as long as it's not raining, I'll be here basically every Saturday for a while.
Awesome.
Putting my time in for my project. So if you think of something or you want to come by and say, hey, what do you think about this? And if you got a gotcha, just come by some afternoon and sit
What
down
did you
and
think
talk.
about?
All right.
Did you see the Stephen Hawking Curiosity bit? I don't know, like what it was pretty much talking about the Big Bang Theory, and all I got out of it was he talks about something about black holes, and they're like not like time doesn't exist in black holes, and like before the Big Bang Theory, time didn't exist because it's kind of like a human concept, I guess, time. And what he said was there's nothing before the universe, so there's nothing before the universe, so therefore like God couldn't have created it.
Yeah,
So-
I didn't see this, but I did hear a very well-known and probably the best well-known apologist. Do you know what it means to be an apologist?
No.
Apologist is someone who defends the Christian faith. So I aspire to be an apologist in training. But one of the best known is William Lane Craig, and I heard his podcast where they talked about this specifically, and it's been a challenge that's come to him. Really, at the heart of Stephen Hawking's argument is circular reasoning. He is saying that no time exists before the Big Bang, and obviously space-time would not exist before. The time that you and I experience, that we measure by the vibration of the cesium-133 atom, that time obviously does not exist prior to the Big Bang. But to say that there's no time, like there couldn't be God's time before the Big Bang, presupposes your conclusion that there is no God. So to say that God couldn't have experienced time prior to creating a physical universe, and then saying since that there was no time prior to the Big Bang, then there's no way God could have acted, is circular in its reasoning. Do you see how that?
Yeah, I wasn't really arguing because I grew up Catholic and everything, and my parents are pretty religious, and I still go to church on occasion, but I'm not completely sold on the whole idea of there being a God. But
the biggest argument in cosmology today against God, as far as the design type argument, is that there's a multiverse. so that there are an infinite number of universes, all with different constants.
Yeah.
And there's this multiverse generator that generates millions and billions, an infinite number. And so we shouldn't be surprised that one of the universes has the constants that are tuned for life. The problem is Penrose, who co-wrote the first book with Stephen Hawking, says that if there were multiverse, what we experience right today would be different. And I don't know the details to go in with you, but that's a place to look into.
I know about the multiverses from that Family Guy episode. So.
Yeah. But then the cosmological argument still is in effect. Instead of the universe coming into existence, this multiverse generator has to come in existence somehow. This highly well-tuned mechanism to spin off universes that guarantee there's both an infinite number of universes and that they all have varying constants, so all the combination of constants get hit, really actually makes it worse on the atheist. The other thing is that are you familiar with quantum mechanics at all?
The basics.
Yeah, so there's this vacuum energy that's in the universe, and out of a vacuum energy can spawn a positron and a negatron.
Right.
Or electrons, what we normally call them. And then, because it's the positive and the negative, and then they mutually annihilate and they go back into the vacuum energy. Well, some have argued that, well, the universe could have just sprung up from the vacuum energy, and that's, how we see everything. But when they say, they equate nothing with vacuum energy, and vacuum energy isn't nothing, it is something. It exists in space and time. So the vacuum energy, even if it's nothing compared to a particle, it is still a thing. It is not no thing. So it would still.
Vacuum energy.
You have not?
You mean like dark energy?
No, it's the particle energy that's just in the background of everything that we have, and so it's the swirling energy out of which all of our particles kind of live and exist. And we have antimatter and matter, and when they combine together, they kind of go back into this vacuum energy. And so the idea is that there's this huge positive matter and antimatter thing, and which in itself you would need to explain why is there, we have like a huge amount of matter as compared to antimatter, and you would think they'd be balanced even on that model. But even on that model, you'd have to explain where does this vacuum energy come from. So
something to think about.
Something to think about. Thanks.
Definitely.
Let y'all get back and get out of the rain before we do get hit by lightning.
Very true.
All right. Thanks, Patrick.
Do you want some
Thank you,
water?
guys.
Patrick?
And what was your name again?
Derek.
Derek. All right.
Nice
Thanks,
to meet
Derek.
you. Did you
Nice
want
to meet
some
you.
I'm fine, thank you. Our pleasure.